This is 2014 FRQ number 4 on the non-calculator section. Train A runs back and forth on an east-west section of railroad track. Train A's velocity measured in meters per minute is given by a differentiable function v of a of t, where time t is measured in minutes. Selected values for v of a of t are given in the table above. Okay. Find the average acceleration of train A over the interval between 2 to 8. So average acceleration means the average slope, because acceleration is the slope of velocity, right? So velocity right here. So you are looking for the slope. So you're looking for v of 8 minus v of 2 over 8 minus 2. v of 8 is given in the table negative 120 minus v of 2, 100 over 6. That gives me negative 220 over 6. Negative 110 over 3, and this is minutes, not minutes, this is meters per minute, right? That's the unit, meters per minute, so meters per minute squared, okay? That's the average acceleration. Do the data in the table support the conclusion that train A's velocity is negative 100 meters per minute at some time t between 5 and 8? So again, this is one of the things you did on AP Classroom. So this is a very good example of intermediate value theorem, IVT, all right? So how do we know that? Well, v of 8 is negative 120, v of 5 is 40. In order from 40 to get to negative 120, it must pass through negative 100. So first you want to talk about the fact that this is, it's a differentiable function. If it is differentiable, it is continuous. It has to be a continuous function for IVT to apply. So you gotta talk about that. You gotta say that VA is differentiable, right? That will conclude the fact that it is continuous. So therefore, IVT apply. V of 5 equals 40. V of 8 equals negative 120. Therefore, there must be v of c equals negative 100 sometimes in the interval between 5 and 8 minutes. Okay, and that's it. All right, part C. At t equals 2, train A's position is 300 meters east of the origin station, and train is moving to the east. Write an expression that involves an integral that gives the position of train A in meters from the origin station at t equals 12. So at t equals 2 and then t equals 12, all right? Use a trapezoidal sum with 3 subintervals to indicate it by the table to approximate the position of the train at t equals 12, okay? So what is the train's position? So position, well, it says at t equals 2, it's already at 300 meters, all right? So we gotta start with there. So at 300 meters, and then now you wanna add up the integral, because this is the rate at which it is going, from 2 to 12 of v of a of t dt, right? We're going to use trapezoid sum to figure that out. So what is that? Well, these are the 3 subintervals, 1, 2, 3. So trapezoid says 1/2, so the height is the difference between these two, so that's 3 times base 1 plus base 2, so 140 plus 1/2. The next difference between these two, the height of 3, and then base 1 plus base 2, negative 80. And then 1/2 between these two, that's 4. And then the height, base 1 plus base 2, negative 270. All right. Now add them all up, you get negative 450. You're gonna add the 300 that you had before, so you get negative 150. So what does that mean? Well, it means that this train was going east and west, right? So a positive position means it's going to the east, and a negative position means it's going to the west. So negative 150, so at t equals 12, train A is 150 meters west of the station. Okay, all right. A second train, train B, travels north from origin station. At time t, the velocity of train B is given by this function here. And at t equals 2, the train is 400 meters north of the station. Find the rate in meters per minute at which the distance between train A and train B is changing at t equals 2. So this is your favorite. This is your related rates. All right, part D. So the idea is that here's your origin station, right? And B is traveling up north, so B is going this way. And A is going away from the station. Let's see, so the A is traveling east, right? All right, so this is A. So how fast are these changing? So this is a very good typical Pythagorean theorem problem, okay? So what do we know? So at t equals 2, right? This is our x, this is our y, this is our z. Okay, so what do we know? We know that at t equals 2, my position is 300 meters based on the problem up here, right? So x is 300 meters. How fast is train A moving? Well, up here it says train A at t equals 2, the velocity is 100 meters per minute. All right, so 100 meters per minute, okay? What about y? What is my position? So it says at t equals 2, the train B is 400 meters away, okay? How fast is it going? Well, I need to know this. So I have the velocity. I don't know what it is though. So I'm gonna plug in t equals 2 into my velocity. So off to the side here, I go v of 2 is negative 5 times 4 plus 120 plus 25. So negative 20 plus 145, that's 125. So 125 meters per minute, okay? So that gives me a lot. Now what else do I need? I need z. So based on Pythagorean theorem, 3, 4, 5 is a Pythagorean triple, so z is 500. So this is what I want. I don't know what dz dt is. How fast is the rate? How fast is this changing between the two of them? All right, so Pythagorean theorem says x squared plus y squared equals z squared. 2x dx dt equal plus 2y dy dt equals 2z dz dt. They all have a 2. Lovely. So really, x dx dt plus y dy dt equals z dz dt. So 300 times 100 plus 400 times 125 equals 500 dz dt. So through 30,000 plus 4 times 125 is 500. So that's 50,000 equals 500 dz dt. So that's 80,000 equals 500 dz dt. So if you divide by 500, so the 800 divided by 5, dz dt is 160 meters per minute. That's how fast that distance between them is changing.